Over the next few slides, we'll look at practical applications, calibration techniques, and best practices to ensure precision. Let's get started. Let's talk about what a thermometer actually is. Basically, it's a device used to measure temperature. In the kitchen, food thermometers are essential tools. They help us check the temperature of food, the surrounding environment, and even surfaces. This is really important for ensuring food safety and quality. When taking readings, you can record them in either Celsius or Fahrenheit, depending on your preference or the standards you're following. Remember, accuracy is key. And a quick note, never use a glass thermometer to check food temperature, as it can be dangerous and isn't designed for that purpose. So, understanding how to correctly use these thermometers is a fundamental part of maintaining proper food handling and safety. Now, when it comes to food thermometers, I highly recommend using digital thermometers because they tend to be more accurate and easier to read. Basically, there are two main types of thermometers you'll find in the market. These are the most commonly used options, and each serves a different purpose depending on what you need to measure. The first type is the probe thermometer. This one is primarily used for measuring the core temperature of food, like meats or other cooked dishes. It's inserted directly into the food, giving you a precise reading of what's happening inside. This is especially important for ensuring food safety and proper cooking. The second type is the laser thermometer. Unlike the probe, this one measures surface temperature from a distance using a laser. It's great for quickly checking the temperature of surfaces, such as the outside of a roast or a pan. Both types are useful, but understanding their differences helps us choose the right tool for the task at hand. This knowledge ties into our overall goal of ensuring food safety and quality through accurate temperature measurement. Now, let's talk about the very first step in proper food temperature safety: sanitizing the probe. The part of the thermometer that actually goes into the food needs to be kept spotless. It's essential to sanitize it both before you use it and after you've taken the temperature. This helps prevent cross-contamination between different foods, especially when dealing with raw meats or other potentially hazardous items. To do this effectively, I recommend using an approved food contact surface, sanitizing solution, or alcohol swabs. These are reliable options to ensure the probe is clean and safe to use. Remember, maintaining this step is crucial in keeping food safe and preventing the spread of bacteria. This step ties into the overall theme of proper food safety protocols, where small but consistent actions make a big difference in protecting health. So, always make it a habit to sanitize your thermometer probe diligently. Your customer's safety depends on it. Now, let's move on to the next step, taking the temperature reading. First, make sure your thermometer is switched on and set to the Celsius scale. This is important because Celsius is the standard for food safety measurements and helps us maintain consistency. When you're ready, insert the thermometer's stem into the thickest part of the food, usually the center. This ensures you're getting the most accurate reading, since the center tends to be the last part to heat through evenly. It's also crucial to avoid taking the temperature while the food is still in contact with a heat source, like a stove or oven. If the food is hot and touching the heat, the reading could be falsely high, which might lead us to think it's safer than it actually is. So always wait until the food has cooled slightly, or at least is not in contact with direct heat before measuring. This small step helps us get a reliable temperature, which is key for food safety and quality. Remember, accurate readings are vital for ensuring our food is safe to serve and meets health standards. All right, now let's move on to step 2, taking the reading for frozen products. When dealing with frozen food, it's important to understand that you can't just use a regular probe thermometer like you would for chilled or cooked items. The reason is that frozen products present a different challenge. The temperature measurement can be tricky if you try to penetrate the ice and frozen mass with a standard probe. If you don't have a specialized corkscrew probe thermometer, don't worry. Instead, you can insert a regular probe thermometer between two frozen units, kind of like in the gap, so you get an accurate reading without forcing the probe into the ice. This method helps ensure you're getting a true temperature reading without damaging the product or the equipment. The key takeaway here is that when measuring frozen products, always use the appropriate technique or tool. Using the right method helps verify that your frozen goods are stored at the correct temperature, which is critical for safety and quality. Remember, proper temperature measurement isn't just about compliance. It directly impacts the integrity of the product and your overall food safety standards. Now, when it comes to taking a reading, it's important to focus on the space between two frozen units. Think of it like measuring the temperature or checking the condition without disturbing the food itself. The key here is to avoid trying to penetrate or cut into the frozen food, because that can cause damage or false readings. Instead, you want to position your thermometer or measuring device in the gap between the frozen sections. This ensures you're getting an accurate reading of the temperature without risking contamination or compromising the integrity of the food. Remember, the goal is to assess the temperature properly while keeping the food intact and safe. So, always be mindful of the placement and avoid breaking the frozen barrier when taking your readings. Now, let's talk about the third step in taking an accurate food temperature, which is to wait until the reading is set. After inserting the thermometer stem into the food, you need to wait at least 15 seconds before recording the temperature. This pause allows the thermometer to stabilize and give an accurate reading. It's important because rushing this step can lead to inaccurate measurements, which could compromise food safety. For liquid products, it's helpful to stir the liquid either before or while you're measuring. Stirring ensures that the temperature reading reflects the overall temperature of the product, rather than just a hot or cold spot. This step is especially important for liquids, because they tend to have temperature variations more than solid foods. Remember, patience here is key. Waiting for the thermometer to settle and stirring liquids when needed are simple but crucial steps to ensure you're accurately monitoring the food's safety temperature. This helps us maintain proper food safety standards and deliver safe, high-quality meals. Now let's move on to step 4, rinsing the probe. After you've used the probe, it's crucial to rinse it thoroughly. This step helps ensure that any residual debris, stains, or oily substances are washed away. Rinsing isn't just about cleaning, it's about preparing the probe for its next use, maintaining accuracy and preventing contamination. When you rinse, think of it as a pre-cleaning step that keeps the probe in optimal condition. Remember, a clean probe leads to more reliable results and extends the lifespan of your equipment. So, take a moment to rinse carefully. It's a simple yet vital part of the overall cleaning process. Now, let's move on to step 5. Sanitizing the probe. It's really important to sanitize the thermometer probe both before and after each use. This helps prevent cross-contamination and keeps everything hygienic. The best way to do this is by using a wet wipe that's available in the kit. Just wipe down the probe thoroughly to remove any residual substances. If a wet wipe isn't available, don't worry. You can use a food-grade sanitizer as an alternative. This is also effective in killing bacteria and ensuring the probe stays clean. And in a pinch, hot water above 82 degrees Celsius can be used to sanitize the probe. Just make sure the water is hot enough to effectively disinfect the surface. Remember, proper sanitation of the probe isn't just about following procedures. It's about maintaining food safety standards and protecting everyone involved. By consistently sanitizing the probe, we're helping to prevent the spread of germs and ensuring accurate temperature readings. So, always make this step a routine part of your process. Now, let's talk about what calibration actually is. Essentially, calibration is the process of verifying whether your thermometers are giving you accurate temperature readings. It's about making sure that when you check a temperature, you're confident that the measurement is correct. To do this, we cross-check the thermometer reading against a known, reliable temperature. This helps us determine if the thermometer is reporting accurately or if it needs adjustment. There are 3 main ways we perform calibration. The first is the ice point method, also known as the ice slurry method. Here, we use the fact that pure ice melts at 0 degrees Celsius, so by immersing the thermometer in a mixture of crushed ice and water, we can see if it reads 0. The second method is the boiling point method. In this case, we check the thermometer against the boiling point of water, which is 100 degrees Celsius at standard atmospheric pressure. This helps us verify if the thermometer accurately reflects high temperatures. Lastly, we have the reference thermometer method. This involves comparing our thermometer to a highly calibrated, certified reference thermometer. It's a way to ensure that our measurements are aligned with a trusted standard. Overall, calibration is essential in maintaining the accuracy of our measurements, especially in environments where precise temperature control is critical. It's a key part of ensuring quality and safety in our processes. Now, let's talk about the ice slurry or ice point method for calibration. First, you'll want to fill a container with about 60% crushed ice and 40% water. This creates a stable, near-freezing mixture that's ideal for calibration purposes. Next, insert the thermometer stem into this mixture, making sure that the sensing area is fully submerged. It's important to avoid touching the bottom or sides of the container with the stem, as that could give you an inaccurate reading. Once the thermometer is in place, wait for about 30 seconds or until the indicator stops moving. This ensures the temperature stabilizes. Now, when you look at the reading, if it shows within plus or minus 1 degree Celsius of 0, that's perfectly acceptable. Slight variances are normal, but anything beyond that indicates a need for calibration. If the reading is off by more than 1 degree, simply long press the reset button to calibrate the thermometer. Remember, the ice point or ice slurry is known to be exactly 0 degrees Celsius, or 32 degrees Fahrenheit. This method is reliable because it provides a consistent reference point, connecting back to our overall goal of ensuring accurate temperature measurements. Accurate calibration is essential for maintaining the integrity of our temperature readings in all applications, so it's worth taking the time to do it carefully. Now, let's talk about the boiling point method. The temperature of boiling water is already known. It's 100 degrees Celsius or 212 degrees Fahrenheit. When you're using this method, you want to put the thermometer stem or probe directly into the boiling water, making sure that the sensing area is fully submerged. It's important to wait about 30 seconds or until the indicator stops moving. That's when you know the temperature reading is stable. Remember, the thermometer stem or probe must stay in the water the entire time, but it shouldn't touch the bottom or sides of the pan. Contact with the pan can lead to false readings, which we definitely want to avoid. Now, if your reading shows a variance of plus or minus 1 degree Celsius, that's still acceptable. Small fluctuations are normal and expected. However, if the reading deviates more than that, say beyond plus or minus 1 degree, then it's time to calibrate. To do that, simply long press the reset button, and your thermometer will recalibrate to ensure accurate readings. The key takeaway here is that by following these steps carefully, you can reliably verify and maintain the accuracy of your thermometer, which is essential for precise temperature control in your cooking or food safety processes. Now, let's talk about the reference thermometer method. Essentially, we use a thermometer that already has a valid calibration certificate, which means it's been officially calibrated by a reputable third-party company or the manufacturer. This ensures that the reference thermometer is accurate and reliable for calibration purposes. When calibrating the thermometer that we want to check, we place both the device under test and the reference thermometer into the same hot water. It's important that they are both immersed equally, so we get consistent readings. At the same time, we note the readings from both thermometers. This simultaneous measurement helps us compare their accuracy directly. The key point here is to look at the difference between the two readings. If the difference is within plus or minus 1 degree Celsius, then the reading from the device under test is considered acceptable. This tolerance accounts for minor variations, but still ensures reliable performance. This method is quite practical because it allows us to quickly verify accuracy against a trusted standard. It also reinforces the importance of having a properly calibrated reference thermometer in our calibration process, which ties back into the overall theme of maintaining measurement accuracy and quality control in our processes. Thank you so much for being here today. I really appreciate your time and attention throughout this presentation. Before we wrap up, I want to remind you that you can scan the QR code on the screen to easily download the PowerPoint slides.